is page 53 in your textbook. Therefore, you can take out your textbook and then we can go through this one. Okay. We are going to talk something about misuses of statistical diagram. Okay, misuses. Okay. If you still remember last time I explained the meaning of the word misuse. Okay, it means some people may use the diagram in a wrong way. Okay, that is misuses. Okay, there are some cases people may just misuse the diagram just by mistake. Okay, or they don't quite understand the purpose for the diagram. That's why they misuse it. But in some other cases, people misuse the diagram to just it's a kind of cheating or want to trick the others. Okay, and then we will look at those examples. Okay, later today. Before we look at those examples, you can look at this class activity first. Now, this one we go through it together, and then you can fill in this one in your textbook. Now, for this one, let's look at that. Now, there are two broken line graphs being shown here. Okay, and then the broken line graph shows the prices of a toy bear. Okay, of a toy bear. Okay, sold by shops A and B in the last 4 months. Okay, the same bear. Okay, but it is being sold in two shops. Okay, and then there's a broken line graph shows the prices. And then if you look at the graph on the left, okay, and then this one represents the prices of the toy bear sold in shop A, okay, for January, February, March, and April. Okay, and then we can, if I look at the graph, it seems that, okay, first there's a decrease in the prices, and the decrease is quite fast, or the price drops quite sharply in this case, okay, if you look at the line like that, okay, in just 4 months. And then this is the graph, okay, showing the price of the same toy bear, okay, in shop B. And then if you look at this line, okay, it seems that it is quite flat. Okay, of course, if you look at the trend, okay, the prices is also decreasing, but it seems that the decrease is not as serious as this one. Okay, also, okay, talking about the same months. Now, then therefore people may think that if you just look at the graph first just by impression, it means what you feel, okay, by just looking at it at the first time. Okay, you may think that, okay, the prices in shop A, okay, drops very quickly. Okay, but here, okay, if you look at question 1, you are asked to refer to these two figures, figure A and figure B, and then you need to complete the following table. For example, in this case, for shop A, the price in January. And it means you look at the graph, okay, this is for shop A, January, and then you go up to this one and then refer to this one. Therefore, we get 130 here. And then in April, here in April, okay, you go here up to this one, and then it means the price is 122. And then for shop B, okay, we just do the same to read the graph. Okay, January and then you look at this one, you can refer to your own textbook, and then you should be able to find out the price is also 130. And then in April, the price is 100. And therefore, it means for both shops, okay, the price, okay, is the same. Okay, for the starting, the price is just the same, okay, in January, starting at 130. But for shop A, from 130 to 122, it means the prices decreases by $8, right? Am I correct? And for shop B, okay, the prices has also decreased, but from 130 to 100. Therefore, the decrease is $30. Now, therefore, in this case, it is different from the impression, if you look at it. But if you look carefully, why there's such kind of difference? If you look at the label, look at the labels of the graph, and then you can see that here it starts from 130, 120, and then up to here, 130. Okay, the graph, okay, same size, you can see that. But the starting point here is 120 and then 130. And therefore, for each square here, it represents $2. It represents $2. But for this one, the same size, right? But here, start from 0 and then comes to 50, 100. And therefore, same square, but this time, this one represents $50. But this one represents $2. Then in this case, we say that the two graphs are having different scales. Okay, I have mentioned this word scales several times, but just in case you still don't know the meaning of this word, in this case, the same square, but this one represents 50, but this one represents 2. Then in this case, we say that the two graphs are having different scale. And then for this one, you can see that for the toppest one, the toppest value here is 250, but for this one it's 130. Therefore, you can see that when we have the graph of different scales, the impression will be much different. Okay, therefore you can look at how we can answer question 2. Now, after studying the graphs, N has an impression, okay, this one an impression, that the price of the toy bear dropped more rapidly, okay. The similar word is quickly. Rapid has the similar meaning as quick, okay, more rapidly in shop A than that in shop B. We have seen this sentence structure before, than that. This that refer to the price of the toy bear, and then we don't need to repeat those words again. Then we just use one word, that, to represent the price of the toy bear. Okay, drop more rapidly in shop A than that in shop B. Do you agree? And then why? Now, first of all, if we look at values for shop A, the decrease is just $8. But for shop B, the decrease is $30. Therefore, it is no. Okay, the prices drop in shop A is not more rapidly, and then you just explain in this way because the price dropped $8 in shop A while the price dropped $30 in shop B. And therefore, in this case, if you look at this part, this is the explanation, okay? The graph in figure A looks steep. If a line looks like that, and then a line looks like that, then in this case, this one is steeper. Okay, and then the one here, okay, is steeper than that in figure B. This may mislead. Okay, do you still remember last time I talked about these words: mistake, misuse, misplace, and here mislead. Okay, and then here it means something. If you use it in a wrong way, then it is misuse. If something you place in a wrong place, okay, and then you misplace the stuff. And then this one, it means you lead the others in a wrong way, then it is mislead. Okay, for lead, if you know the meaning of leader, then this is the verb. Leader is the person. Okay. Right? Okay. Any problem? Therefore, in this case, okay, it means this diagram, okay, if we use different scale, okay, in our diagram, this may mislead the readers, okay, to think that the price of the toy bear show, in this case, by shop A drops more rapidly, okay? And for this case, the truth is that the price of the toy bear show by shop B, okay, drops more rapidly. Okay, therefore, I would like to show you one more diagram. Okay, if you turn your book to the previous page, this one, okay, on page 51. Now this one, if you can see that we skip the values here, right? For this one, okay, we skip the values here, okay, and then we start from here 1,000, and then the square here, this length represent 100. You can see that from the next one is 1,100, and then this 1,200. And then this case, the graph looks like that. But if I redraw the diagram, you can compare this one, okay, with the one in your textbook. Okay, it looks like that. And then if I draw in this way, okay, if I don't skip the values, then I start from 0 here, okay, and then this square represents 100, but I start from 0. Then in this case, because for this graph, the values is from 1,000 to 1,200 only, and therefore you can see that it just squeezing this part. This part is empty, and then this one, it looks not so steep. Okay, compare this one. It means the change. Okay, this one, okay, go up, go down, go up again. Okay, the change, especially for this part, if I move it in this way, if you look at this line and this line, okay, this line is steeper. In this case, steeper. Okay, then it means it looks like that the increase is more rapidly compared with this one. But actually, they are just the same, okay, because they are from the same data. Okay, Now, therefore, it means how you draw the diagram can affect the impression, can mislead the others. Now, of course, then in this case, you may ask me why we need to skip the value then in this case. Now, if we skip the value, okay, if you look at this one, this is the proper way. We add this symbol. For adding this symbol, it just remind or make the reader alert. Okay, you tell the reader, I have skipped some values. Pay attention. Okay, therefore, the reader, when they read the diagram, they know that they will have a more they they will understand that's why it just focus on this part only. Okay, but for this case, you look at this one again. Can you see that there's no such symbol? Okay, it means for this one, the difference between these two, okay, for this one, it has skipped some of the values, but it does not include the symbol. Therefore, people may not be alert that some values are skipped. Okay, they may think that, okay, it's also start from 0. Okay, then therefore, it means it seems that some information is hidden in this case. Right. Now, there are some more examples shown in your book for the misuse of diagram, just like this one, same as the one before. It starts from 945. It is okay if you want to start at this point, but you need to tell people that some of the values have been skipped. Okay. Can you see that? Then therefore, you may think that in this case, you may think that now first of all, how you think about the graph is this part, impress. Okay, therefore, this one, the broken line graph gives reader an impression that the consumption of drinking water has big changes over the year, because you can see that it looks okay, up, down, okay, very quickly. Okay, therefore, it looks like that the changes are very big. But if you look at the exact data, okay, it means if you really look at this part, okay, the maximum, the highest one is here, 974. Okay, this is the highest one. If you refer to this one, 974, and then the minimum, the lowest one, this is the lowest one. Okay, if you read this value, this is 949. In this case, okay, the change, okay, you are asked to calculate the percent, okay, the percentage change, okay, and then we use the lowest one to be the original value. Do you still remember? Okay, we need to take the original values to be the denominator, and then the change, okay, therefore we do the difference, okay, 974 minus 949, and then in this case the change is just 2.6. It means from the smallest values to the biggest value, the change is just 2.6%. okay, it's not that big. Okay, therefore in this case, when you are asked for part C, is the given broken diagram misleading? In this case, this is the adjective. Okay, we have mislead. This is the verb. And then if the graph is misleading, then in this case it's adjective. Okay, explain your answer, and then you can refer to the answer on the next page. Okay, it is misleading because when someone has calculated the percentage is not that big. It's quite small, just 2.6%. But if you look at the graph, it seems that the changes are very big. Then in this case, you can say that the broken line graph is misleading. Okay, and you can you can see quite a lot of examples given in your book here. And then this is the other kinds of diagram which can be misleading. And then you can see that for this one, okay, instead of using just a bar, okay, usually, okay, when you use bar chart, okay, if you still remember when you learned it in primary school, I think your teacher has told you that for keeping this width, keeping these two width to be the same, okay, so that you can just look at the height, okay, of these two bars, and then to tell which one has more frequency. But for this one, okay, instead of using bars, okay, it uses similar triangles. Do you remember? These were similar triangles. Okay, the size are similar, the shapes are similar, but the size are different. Now, therefore, in this case, if you look at the height here, 1, 2, 3. For this one, if you look at the number of square, for this one, okay, 3. And then for this one, 1, 2, 3, 4, 5, 6. Okay, this 6. Okay, I mean, I just count the number of square, double, 2 times. And then if you look at this part and this part, okay, also this one will be 2 times of this one. And then if you look at these two diagrams, I don't know whether you have this kind of impression. This one seems very big, much bigger. Okay, because in this case, if you now referring to the case of bar chart, if I keep this one, okay, if I keep this length, okay, to be the same, then it means I just measure one dimension, one length. Okay, this one is longer than this one, right? Just one length. But for this case, there are two lengths longer. Okay, the height, if you refer to the height of these two triangles, okay, this one is double this one, right? And then if you look at the base, this is another length, okay? Then this length is also double this one. Then in this case, it gives you an impression that this one is much bigger. You can try with other diagram. I can try the drawing here. Now, for example, if I have a rectangle like that, if I try to double both, okay, then this one becomes doubles like that. For this length, okay, 2 squares becomes 4, right? Now, then if you look at these two, okay, the impression that this one is much bigger than this one. Am I correct? If I keep this one the same, if I just double one length only, now then you look at these three diagrams. Okay, if you compare these two, okay, of course you know that this one is bigger than this one. But if you look at these two, the impression is much different. Okay, this one seems much bigger. Okay, because when you look at the diagram, we don't just look at the length. Actually, we have the impression of how big this part, how big the region. Okay, therefore, in this case, if I use these two similar figures, then I can create a much bigger diagram because I double every length. Okay, therefore, you can look at the other example here. If you look at this length, this is the real difference. Okay, but if you look at these two, okay, this one seems very tiny, right? This one seems very big. Okay, therefore, in this case, this is it means some people may use these kinds of techniques to mislead the others. Okay, so that it just gives you an impression that okay, in this year, okay, the values for this one is very big. Okay, right. And then some people may give you the let me explain this one. The explanations, I think. Right. Now for this one, the pie chart below shows the grade. And then for this example, this is another example to mislead the others. If you look at this one, okay, and then this one, okay, is unknown. This one is unknown, okay, and then if you just this one is unknown, and then this one is very small, right? And then look at the first one, part A. In S1A, can you see the question? You can see it, you can read it in the textbook, right? This is class 1A, okay? The number of students obtains grade B, okay? It says greater than that obtaining grade A, okay? Explain your answer. It means if you look at this, okay, do you think that the number for this one is bigger? What do you think? Anyone? You can type the answer in chat if you want to answer. And because I think if I'm sharing the iPad, you cannot write anything. Now, and then for part B, okay, what you need to answer, okay, based on the these two charts, Matthew, okay, someone concludes that there are more students obtaining grade A, okay, if you compare this part, more students obtaining grade A in S1B than S1A, do you agree? Explain your answer. Can you see the difference? For part A, it means you just look at one diagram only. If you just compare this diagram, if this one is correct, do you think that more people are here having grade B? Do you think that more students are having grade B? Do you think that? Okay, someone answer yes. Okay, right. Now, how many percent actually here? What is X? What is X? Anyone knows how to find it? Can you find X? Can you find X? First of all, usually we would like to check whether the diagram is correct. Okay, and therefore, what is X? Okay, 1 is 40. The total should be 100, right? And then we use 100 minus 40, minus 15, and then minus another 15, and then minus 20. And then this one is 10%. X should be 10. Okay, maybe I'll write here. Okay, 10%. Therefore, I think this one is correct. Okay, this one is smaller than this one, right? Okay, and then it means the diagram, first of all, the diagram is correct. Okay, 10% of S1A student, okay, of course, okay, is less than 15% of S1A student. Okay, okay. Oh, it's blocked like that. Sorry. Oh, my iPad. Okay, sorry about that. Okay, of course, 10% is smaller than 15% if we talk about the same class. But the problem is that if I compare the two classes, what do you think? This is 10%, 10% of S1A gets grade A, and 20% of of S1B gets grade A. Okay, do you think that the actual number of students in B class, okay, is greater? Someone agree. If I look at the message, you agree, someone don't agree. Now, if you turn your book, maybe S1A. Now, for example, if S1A, but you don't know the number of students in both classes, how about if for S1A, if there are 50 students, okay, 10% of 50, how many? If this class S1A, okay, there are 50 students, and then 10% of 50, how many? 10% of 50 should be 5, right? But if it happens that if they're in S1B, okay, if the S1B, there are only 10 students, 20% of 10 students, how many? For example, Adrian, I just give an example so that your classmate can understand more clearly. Now, in the case if, okay, if there are 10 students in S1B, then in this case, 20% of 10 students, then it becomes 2 only. Now, therefore, in these cases, it means the actual number of students of each class, okay, can actually affect the number. This 10% here is 10% within this class. Therefore, if this class has 50 students, then 10% of this class will be 5. If this class has 10 students, then in this case, 20% of 10 will be 2. Of course, 15% is, in this case, is really funny, okay? But I just want to show you, if you compare the percentage, you cannot compare the percentage like that, because one is talking about A class, the other one is talking about B class, different classes. Then in this case, for different classes, then we cannot compare the percentage, okay? Because this 20% will be 20% of this class. If this class has 10 students, then 20% will be 2. Okay, therefore, in this case, even if I look at the percentage for class 1B, the percentage is bigger. Okay, but it does not mean that, okay, the actual number is really bigger. Okay, therefore, in these cases, if you look at the whole questions, actually the number of students for S1A and S1B are unknown. Okay, therefore in this case we cannot tell. Actually we cannot tell. Maybe, okay, if there are more students in S1B, then of course 20% of this class is bigger than 10% of this one, but we never know in this case. Now, therefore, this is also kinds of misleading diagram, okay? Because you just have the diagrams only, and then people usually are attracted by the diagram, right? Because diagrams are easily to read, okay? It is easier for you to read the diagram. Therefore, usually people will quickly look at the two diagrams in this way. And then will quickly, okay, people may mislead you. You can see that, okay, the students in class 1B are much better because you can see more people in this class can get grade A, okay? And then usually if you just follow the diagram without thinking, okay, or you don't think very carefully, then you will be misled by the others, like that. Of course, if you look carefully, then you may ask, okay, how many number of students are there in each class? Okay, oh, if we don't know the classes, then we don't know the number of students, then we cannot tell. Okay, that is the way people may mislead you. Okay, there's sometimes the diagram have not enough information. Okay, some information will be hidden. Okay, now the case is that I'm not going to go through too many examples, okay, but you can have a quick look of those examples in your exercise 1E. Okay, I think for exercise 1E, there are two kinds of exercise. Okay, the first one, okay, the first one, okay, just like this one. You are asked to choose the number of, not the number of, choose the suitable diagram to present the data. I think you can try this one, okay? Instead of looking the answer, you can first of all look at it and then check the answer by yourself, okay? Because this part is more useful to you at this moment, okay? You may be asked to do some simple study, okay, to collect data. Then after you have collected the data, then you should know how to choose a diagram to show your data, to present your data. Okay, therefore, these kinds of questions are more useful to you at this moment. Okay, and then of course, you can have a look of the others. This one is about the misuse of the diagram. Okay, of course you can try to look at it. Okay, now at this moment you may find some difficulties in explaining what you are thinking in English, but doesn't matter at this moment. But the most important is that, do you think that, for example, for this one, do you think that this diagram is misleading? And then do you know why? Okay, can you think of the reason, okay, why it is misleading if you think that it is? Then you can just refer to the answer, to your model answer in your textbook, and then try to learn how to, first of all, you look at the model answer, see whether you agree with the answer. If you agree with the answer, then you can just try to learn from the model answer, see how you write the sentence to explain the diagram. Okay, now for this one, the explanation, the explanation is quite simple, okay? Is this a fair comparison? Okay, then the answer is no, because it is not fair. It is, or the other word is misleading, because the diagram misleads the readers by using areas of the figure. It means this part is much bigger than this one, okay? How do we say that this part is much bigger in this one? In this case, it means the area of this circle is much bigger than this one. Therefore, okay, we can use area, okay? We can use this word area, okay, to do the explanation, okay? Right. And then we can focus on those exercise, okay, in supplementary exercise from tomorrow, okay? I would choose, okay, some of the exercise, okay, and we will do it together, okay, and then for your revision, okay? And then I think, okay, you can check Google Classroom later today. I will select some of the question in supplementary exercise 12 for our lesson starting from tomorrow, or for our lesson this week, okay? Right, and then make sure that you have paper and or also graph paper with you for the remaining days, because we need to do the exercise together, right? Any questions up to this moment?